So, the pull request is merged.
Yes.
In a surprising turn of events. So, what's next?
So there's the thing, and I'm putting a link to the chat to the test run of RPM. I have reopened the pull request regarding ASIN options and rerun the CI. And as you can see, it's got a color we don't like that much, and it's got things in it.
Leaks. Oh, this checks for leaks?
Apparently.
Well, we did identify the leaks, right?
We also fixed some leaks, but apparently there are more.
So let's see. Can use the main branch now, right?
Yeah, master, I guess.
So where was the leak we found? It was somewhere in one of these objects.
Yes.
Attaching something.
Oh.
Or well, maybe we can look at the leak check results, right? So this is header create. Header from FD number. Header blob read. Header from FD number. Header from FD number. Header from FD number. And RPM TS pi. Okay. So this we'll call RPM read package file, which calls into RPM, and that is never closed, released, whatever. So RPM read package file will call our HDR blob import header create. So this will create a header that is never released. Okay. Read package file. We'll do RPM RC. That's the return value. This H is probably the thing that doesn't get released, right? And this calls HDR wrap on that H and puts it in a ho, which is then returned. And interesting that we're leaking this, but nothing else. At 36 allocations. the other allocations? Oh, detecting memory leaks. Number. Can you reproduce this locally?
Let's take a look. So I would. Oh yes, of course. RPM Sequoia. Yes.
So this looks like it. Oh, it's leaking 24 objects with the same traceback.
Sequoia. Where are you? I don't know. This now. Looking for it. Yeah.
So how is this built? So this is a closed pull request?
Yes, it's called.
Oh, run Python test with ASAN. Okay, so I'll sure pick that one as well. I must have a different sanitizer. So this is GCC, right? sanitize leak. How did a sanitize leak get in here? Sanitization is done in CMake lists. Ah, enable ASAN, enable UBSAN. That's what I need. Enable ASAN. We'll do sanitize address, sanitize undefined, but I don't see the leak checking. Underscore get. This is extra path. How do you configure CMake? -D option.
Yes, it should be -D. We did it for enable the phone.
Equals on?
I don't know if the space is, if it can handle space. We did it without.
I don't know if you can enable both sanitizers at once. Probably.
Okay, great. Okay, again, CMake -D enable test suite on, I guess.
Ah,
Lost.
de-enable test suite on. Right.
Yeah, I put it to the chat. Yeah, okay, I've got it.
There we go. Build tests, and this is 124. Log, and there it is. Haha, nice.
Oh, and it looks like it's the thing. Great.
1117. This is 44424. So this is the bigger leak, actually. Let's see what these do. So this one 4 times, that's why there are, well, the 4's here. We'll add some RPM to a transaction.
Yeah, transaction set, I guess.
And if there's an error, it will print the error. And if I equals 1, it will make a new transaction. Okay. So it doesn't print any errors. So every one of these add installs, presumably, leaks. What about this one? This one looks a bit simpler. It leaks 1, 1, and 7 objects. This is 4, 4, and 7 times 4, right? What's 7 times 4? I don't know.
No, it's 20.
This is 28. This is 24. So one of those is a different one. That's fine. Okay, so this one looks simpler, right? This one reads this RPM file and like this whole RPM file and adds it. This just creates a header from a file. Okay, so make a header and we print its arch, and then we print an error if there is one, and then close a sync. So there's a log file that might be interesting. I don't see any errors being printed, which is good. That would mean the error is not in a like the bug is not in an error path. There probably is some bug in some error path somewhere, but that's not being tested here. So where is this test at? Tests RPM Python at?
Yep.
Line 221. Reading assigned package file. No, I want the other one. 394. No. This one reads header from file. No, this one. Okay, so let's get rid of the sync first and see what garbage, absolute garbage, well, RPM log will give us. Not this one, 115. So there is a warning. That's probably the one. And there's nothing else. Okay. So we can see what Python does here. Transaction set header from FD number is put in a variable called age, and then we do nothing.
Yeah, I'll just print the arch.
Okay. Okay, So let's see. RPMTS header from FDNO. We looked at this before. I guess that's this header that's being leaked. We call HDR wrap. So that would be probably an RPM. Where's HDR wrap? Header pi. So what do? We allocate the type. Turn header. This looks fine. What else is here? Slots, like dialog traverse. Let's look at those. There's header dialog. Just freeze some header. Apparently this is not being called. Was leaked. Okay. Apparently a bunch of other tests failed here with calling header dialog. So in some cases the header is deallocated. What does this thing do? 106. Maybe this one will be easier. So this calls header dialog 2 times. So this is working with a spec. I guess spec.source header and package header. Okay, so that works. What else is there? 20. This calls add install. What is it about HDR from FDNO? Well, one thing I guess I should also look at is this add install from RPMTS. What? Did my I pressed Control P. RPMTS add install. What does add install do? RPMTS add install element. Oh, this calls header from PyObject.
Mhm.
And it adds an install element with that header. That didn't help. And what's keeping this header alive? If I go to the test and if I do a garbage collection run, that should. Shouldn't really do anything. Is this the one? Yeah. Oh,
Nothing is printed.
oh, 0. Oh, 0.
Mhm.
That's fine. And what exactly is being leaked? Operator new and header create. Is the header somehow not being released? Package file header create. Get FT. Header wrap. Set the header here. And in the dialog we call header free if there is a header, which looks good. Except this function is not being called. What's keeping the header object alive? So it's header from fdno and ts add install, both transaction set thingies.
Mhm.
So hdr from fd number. Something here is keeping this HO object alive. Let me check PyBuild value. This is using n. Doesn't create a new strong reference, useful when the object is created by a call in the argument. So that's fine. So this N means that the ownership of this HO is transferred to the returned tuple. And this returns an integer and this Python object. Oh. HDR from FD number returns a tuple, and this is trying to print arch. What? What is this H? Is this ever printed? So warning. There's the 0. Oh, there might be some expected output.
It should be the test, right? Public key not available.
Oh, there should be an error. Huh. So this print is not supposed to do anything. Right.
Oh,
so
yeah.
We're not getting an error, we're getting public key not available. Ah, it is an error path. So does RPM read package file is there any documentation for RPM read package file? Probably not. Maybe we can look at how it's defined. This one, oh, that's the header. This one, HDRP. So HDRP is set to header link. And then RC is set to something. So I have a theory here. What if RPM read package file sets this header output argument, but then returns an error? How do you determine errors here? But that would have to be one of these return null, right? Wait, what does this do? TS header from FD number returns an error called public key not available. Let me print the wrapper of this error instead. Both so that it shows up in the diff and so we see its type. Error. RPM error. Okay.
So
okay, public key not available.
Currently there is an enum called RPM RC underscore no key, and that one is the one giving the string public key not available.
But where would that be set?
I can't see where. Oh yeah, wait a moment. there is the file Python RPM transaction py. No, just transaction py.
Oh, okay.
And then there is a function, Python function HDR from FDNO. This is the last.
Oh, there's another one.
Last one in the file. Yes. And this is where the error is set.
So you get the result and the error.
And it actually calls HDR from FDNO.
I see. So this raises an error.
Not that one, the first one.
The first one. And if it didn't raise the error, it returns H. Okay. But this assumes that if there was an error, which means RPMRC is not okay, then the H didn't get set. Right? So what we do is I would set header to null, so that if this function doesn't touch it, it remains null. But if you return none here, and this function did touch H, did set it to something, well, I hope H is I hope header is a pointer. Then we need to decref or get rid of this H. How do you do that? You do header free. Right? And this says if H, and so apparently you can use H in an if, and hopefully you can also set it to null. Let's see. Whoa.
Oh, there's the error, the print.
Well, yeah. Okay, so what's left to do here? Don't print the wrapper, don't print the GC, and do set the log back. And there we go.
Oh, cool.
That's it. Right, so apparently this RPM read package file can set H even if it returns an error. That's the culprit here. Were you able to follow that? Did you want the diff?
I don't need. Yeah, that's all right. So what happened is that H got set even if the function ended with an error, and that was never freed.
Yes. Maybe this needs a comment.
Beautiful.
Or maybe maybe another option would be, since putting H here and returning the H. That's probably cleaner, right? Since the RPM-RC, the error code is being returned, and we're also returning the header Python object. Whatever this function returned, we just give it back, basically. Right? So for setting this HO, we look at H and not at the error code.
Oh, okay.
So this makes a simpler diff. It is important to set it to null first, so that if the function doesn't touch it, for example, if it finds an error before it gets to anything, any important code, then it should remain null. Right. Does that... We got 2 errors before, it's all green now, and it's the same errors as in the CI run here, right? 24, 4, 4, 4, 7, 1, 1, 1, and no scary errors before that.
There were 7 failed tests and 5 of that expected failures. So the 2 tests we were looking at are apparently the ones.
Nice.
Okay, so you can fix it.
Yeah.
Great. Magic.
Which leaves us with the problem of what to do next.
Okay, we're back there. I was looking at the list of libraries that we somehow that we evaluated as ones we would like to be ported to stable ABI. There was Selinux and libvirt, and then the NF5 Python bindings. So there are 3 things from a very, very old list that I found somewhere deep there.
Okay. I don't know anything about those libraries, so which one is best?
I have no idea about any of them. I just found them. You mentioned NumPy.
NumPy or Swig.
Swig. Oh, Swig is a... What is that? It's like multi-language compiler to anything, or anything to Python binding?
I think it's C to anything. Not really familiar with it.
C++. Do anything.
JavaScript, Perl, Python, PHP, Python, TSCL, and Ruby. So it generates some kind of glue code. And it has documentation. Building a Python module. Swig-Python example I. GCC with user include will give you an example SO. And then you have a module. Okay. Python on Windows. Swig and Python. Well, this is assuming we want to do DNF or whatever is written in Swig. Maybe we should look at the DNF part first.
Sure. It looks like it uses Swig. How does the thing work?
You might need a very recent Swig. So what are we wrapping? DNF?
DNF5, and it's in the same namespace as RPM.
Oh. DNF5. This one?
Looks like it.
Okay. It can interface with Python 3. Alright, how is that achieved? Bindings? Python 3? CMake lists? Swig stuff? Okay. It has libdnf5 and libdnf5 CLI.
Yes, both containing some sweet CMake magic.
Okay. So is that here? I files. Command.I. If defined Swig Python. Python code. Def class name iter. Okay. Yeah, so there's Swig Python stuff.
Mm-hmm.
Set string. An iterator defined as a Python class. String wrapper. Add hash. Okay, well, it does look like the right project, I guess. And what are we looking for here? We want to build this first, I guess. How do you build this?
There has to be documentation, right?
Development environment setup. DNF build dep DNF5. Build DNF. Make a build. CD build. It's not underscore build, that's good. CMake.
Or CMake with options, but we don't know which ones.
Oh, well, let's ask. Oh, this doesn't give us anything, right? -D. So it was with, right? So let's is there any Python option? With Python 3 on.
And how about tests? Are there any tests?
test with tests on. So that should be on by default. Let's go. We want librepo. We want a new librepo. Great. Okay.
It's a Rawhide. Oh.
So that's a good place to end this because we're out of time.
All right.
Right.
I'll try to figure out it for the next week.
Yeah, I guess I'll just make a container for this thing. Right.